Hello, good day viewers. In this tutorial, we are going to learn how to integrate functions between asymmetrical intervals. And this is exactly what I mean. Suppose we want to integrate the function f of x with respect to x from negative a down to positive a. Negative a down to positive a is a symmetrical interval. What you should know about this solution is that if f, which is our function, if it is an even function, then the integral from negative a down to a of that function f of x with respect to x is the same thing as 2 multiplied by the integral from 0 down to a of the same function. But if that function is odd, if it is an odd function, then the integral from negative a down to a of that function f of x dx is equal to 0. Don't even waste your time. It must be equal to 0. Let me show you this graphically. Suppose we have a graph like this, something like this, from negative a down to positive a, and we have another one like this, something like this, from a negative down to a positive. If you observe, the first graph is an even graph, right? While the second one is an odd graph. So let's start with the even one. This is an even function, while this is an odd function. If you are to find the area here above the x-axis, you should know that the area here must be equal to the area here, right? Because they are symmetrical. So instead of taking the area from negative a down to positive a, you can simply take the area from 0 down to a, then you multiply by 2 because the two areas are exactly the same. So if this is 2, this must be 2. So instead of finding directly from negative a down to a, which is going to give us 4, you can simply take 2 multiplied by the second area, which is 2, and this will give you 4 exactly. But for an odd function, you should know that area below the x-axis is negative, while the area above the x-axis is positive. So if this area is negative a, this must be positive a. And if you add the two together, a plus negative a, this will give you 0. Therefore, on a symmetrical interval, if you integrate an odd function, it is going to give you 0. All right, but how can you determine whether a function is even or odd without graphing? You should know that if you are given a function f of x, this f is even if f of negative x turns out to be equal to f of x. What does this mean? It means that if you substitute x with negative x into the original function, simplify, you're still going to get the original function. If this happens, then that function is said to be an even function. But f of x, f is odd if you substitute f of negative x and it turns out to be negative f of x. Meaning if you replace x with negative x, you simplify, it will be negative the original function. And if this happens, then it says to be what? An odd function. Now let us integrate two functions separately. Let me start with number 1. I would like to find the area of the function equal to 4 minus x squared from negative 2 down to positive 2. You should know that this is an even function, but if you like, you can test it. F of negative x is equal to 4 minus, instead of x, we replace it with negative x, then you square that. This is equal to 4 minus negative x squared is still x squared, which is exactly as the original function. Therefore, this function is said to be an even function. And you can graph it to see it clearly. So we want to find the area between negative 2 down to 2 of the function 4 minus x squared. with respect to x. Because it is an even function, it is the same thing as 2 multiplied by the integral from 0 down to 2 of that function 4 minus x squared dx. So now instead of integrating this, we are going to integrate this, though they will all give us the same answer. This is equal to 2 multiplied by the integral of 4 with respect to x will give us 4x minus the integral of this will give us what? X to the power of 3 divided by 3. You know, you increase the power by 1 and you divide by the new power. Then the limit of integration will be from 0 down to 2. This is equal to 2 multiplied by, you replace x with upper boundary. So we have 4 times 2 here, then minus 2 raised to the power of 3 divided by 3. Then you subtract the lower boundary, which is not necessary because everything will be 0. The moment you plug a 0 here, it will be 0. All this will be 0. So we don't have to. Let's simplify. This is equal to 2 multiplied by 4 times 2 is 8. Minus 2 to the power of 3 is 8 divided by 3. This is equal to 2 multiplied by 3 times 8 is 24. 24 minus 8 is 16 divided by 3. And 16 times 2 is 32. So this is 32 divided by 3. And hence this is the area above the x-axis or under the curve. Now let us take the second problem. I would like to integrate the function from negative pi to positive pi of the function 3 sine x with respect to x. This is an odd function. Remember that sine is an odd function, but if you want to confirm, you can do that. F of negative x is equal to 3 multiplied by sine of negative x. But remember that sine of a negative value is the same thing as negative sine of the positive value. Therefore, we can write this one as negative 3. If you bring out the negative sign, then sine of x. But remember that 3 sine of x is our function f of x. So therefore, this is negative f of x. So if f of negative x turns out to be negative f of x, then that function is said to be an odd function. And hence, the whole of this will give us 0 directly. But let's confirm whether it is 0 or not. We want to integrate from negative pi down to pi of the function 3 sine x with respect to x. 3 is constant, so you bring it out. So you have 3 multiplied by the integral of sine x is what? Negative cosine x. The boundary from negative pi down to pi. So let's substitute upper and the lower boundary. This is 3 multiplied by negative cosine of pi minus the lower boundary will be what? Minus cosine of negative pi. So you should know that cosine is an even function. Therefore, cosine of negative value is the same thing as cosine of the positive value. That is what you should know. Therefore, the whole of this will be cosine of pi. The minus minus is plus, right? So this is 3 multiplied by negative cosine of pi minus minus plus, then cosine of pi. You should look at it. Negative cosine, positive cosine, it will give us 0, right? So this is 3 multiplied by 0, and this turns out to be 0. You see that? Because it is an odd function and we're integrating that on a symmetrical interval, therefore it must give us 0. Definitely. And you can graph it to see how it looks like. The amplitude is 3 because you can see it is multiplied by 3. The function is multiplied by 3. Therefore, it will go height up to 3 and down up to negative 3. We have pi here. We have 2 pi here. We have negative pi here. We have negative 2 pi here. So the function will go up like this, like this, like this, like this. Let me shift this one a little bit to the back. Negative pi. Remember, we are asked to find the area from negative pi down to positive pi. So I'm only concerned with these two curves. Remember that it is symmetrical. The area here is the same thing as the area here. Though this one is below the x-axis, so it will be negative. So if this area is negative a, this must be positive a. And once you add the two areas together, you must get 0. We are talking about net area. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.